Marhaba. Okay, in this session we want to continue studying relations, and we want to discuss several types or several properties about relations. Okay, remember we want to talk about relations on a set A. Okay, which means, so consider a relation R on a set A. Well, again, what does it mean that we have a relation on a set A? It means that we have a subset. R is a subset of A cross A. Okay, quick example. If A is the set 1, 2, 3, for example, we can represent, here's an example of a relation. We have 1, 2, 3. Say 1 is related to itself, and 1 is related to 2, and 3 is related to 2. Okay, so this is an arrow diagram. This is a directed graph, which represent a relation. What is the relation here? It is the set of these pairs. 1 is related to itself, 1 is related to 2, and 3 is related to 2, right? And notice that this is a subset of A cross A. So this is how we defined a relation on a set A. It's a subset of A cross A. So it's a set of pairs. And we can represent it by, we can use arrows and points to represent a relation. Now let's study different types of relations. So let's start by saying that let R be any relation, okay, a relation on a set A. A relation on a set A. So imagine you are given a relation, so you are given information like this one, it's a subset of A cross A. Then we will call R reflexive, so R is called reflexive. So this is the first type of a relation. If for every element in your set, for every A in A is related to A. Remember, this means that the pair AA belongs to the relation R. Okay, so this is reflexive. So it means that, okay, quickly, say A has 3 elements. This means that every element is related to itself. Okay, maybe you have more relations between the elements, but the important thing is that are the red arrows. So for every element, we will find an arrow relating the element to itself. Okay, so if we call these elements A, B, C, then we see that A is related to A. Okay, this means that the pair AA belongs to R. We also see that B is related to B, or BB is an element of R, and similarly CC is an element of R. So if every element is related to itself, then we call the relation reflexive. If you can find one element which is not related to itself, like here, for example, 3 is not related to itself, then this relation is not reflexive. Okay, so these are reflexive relations. Next, we want to define the second type of a relation. R is called irreflexive. If every element is not related to itself. If for every A, in the set A is not related to itself. Okay, so notice that irreflexive does not mean not reflexive, because not reflexive means at least one element is not related to itself. However, irreflexive means no element is related to itself, or every element is not related to itself. So here is an example. So this is a relation where no element is related to itself, and so this is an irreflexive relation. See, there's no arrow from the element to itself. Okay, so this is irreflexive. Now the third type is R is called symmetric. The relation is called symmetric. If whenever an element is related to some element, then that other element is related to the first element. Okay? If a first element is related to a second one, then the second is related to the first as well. So how do we say this? If for every element in A and for every element in in A as well. So now we only have the set A. And notice A could be equal to B. If it happens that A is related to B, then B must be related to A. Okay, so in terms of arrows, whenever you have an arrow, you have another arrow in the reverse direction. This is the meaning of symmetric. Okay, so here is an example of a symmetric relation. So if we have an arrow from this element to this element, we must have this arrow. Okay. For example, this is an example of a relation on a set of 3 elements. So say A, B, C. And whenever A is related to B, so here A is related to B, then B is related to A. And here B is related to B, so B is related to B as well. And C is related to C, so C related to C, and so on. Okay? So this is symmetry. Now we want to define antisymmetric. Okay? So when a relation is not symmetric, if we have one element which is related to another and this other is not related to the first. Okay? This is not symmetric. But now we want to define antisymmetric. R is called antisymmetric. Okay, we'll have more examples once I finish introducing all the types. So what does it mean, antisymmetric? If whenever 2 distinct elements, if the first is related to the second, then the second is not related to the first. Okay, so for every A in A, for every B in A, if A is different from B and A is related to B, then B is not related to A. Okay, again, what does this mean? Choose arbitrary elements in the set A. Call them A and B. And suppose A and B are distinct, they are not equal. And suppose that A is related to B, then it must be the case that B is not related to A. Okay, so here this relation is symmetric, but it is not antisymmetric because A and B are different and A is related to B, but B is also related to A. So this means, antisymmetric means whenever you have an arrow between 2 different elements, you don't have the reverse arrow. Okay, so here is an example. Suppose we have an arrow from this element to this element, and from this element to this element, and from this element to this element. So whenever we have an arrow between, we can have arrows from an element to itself. And notice this is antisymmetric. Why? Because whenever you have an arrow between different elements, for example, look at this green arrow. It's an arrow between different elements. We don't have an arrow in the reverse direction. And you can check every other arrow between different elements. So this is antisymmetric. Now, finally, we want to define transitive. R is transitive. Okay, we've seen this before in divisibility. Remember, if an integer A divides B and B divides C, then the integer A must divide C. Okay, this divisibility is a transitive relation. So R is transitive if whenever you choose any 3 elements in your set, so for every A in A, and for every B in A, and for every C in our set A, remember we have a set and A and the relation R on A, then if suppose A is related to B and B is related to C, then it must be the case that the first, which is A, is related to the third, which is C. Okay, this is transitivity. It means if the first element is related to the second and the second is related to the third, then the first is related to the third. If this is always the case, look, these are universal quantifiers. If it's always the case, then the relation R is called transitive. Okay. Again, what does transitive means? It means if you choose any 3 elements in your set, call them A, B, and C. Choose arbitrary 3 elements. The 3 of them could be the same element anyway. Choose any 3. If the first is related to the second and the second is related to the third, then the first is also related to the third. If this is always true, it's transitive. When it is not transitive, okay, so for example, the first is related to the second is related to the third, so we must have this arrow, A, B, C, for the relation to be transitive. If we didn't have this arrow AC, then it's not transitive, because A is related to B, B is related to C, but A is not related to C. Okay, so let's have 2 or 3 more examples. So I want to give you a relation and we want to see this given relation, whether it is reflexive, irreflexive, symmetric, antisymmetric, or transitive. So let's start with this relation. So example, let A be the set 1, 2, 3, and 4. And consider the relation on A. So what is a relation on A? It's a subset of A cross A, which means it's a set of pairs whose elements are from A. So suppose the pairs are the following. You are given this relation. So 1, 1, 1, 2, 1, 4, 2, 1, 2, 2, and 3, 3, and 4, 1, and finally 4, 4. Okay, notice that this relation is a subset of A cross A. Okay, now the question, is this relation reflexive? What does it mean to be reflexive if every element in A is related to itself? Is 1 related to 1? Yes. Here it is. Is 2 related to 2? Yes. Is 3 related to 3? Yes. Is 4 related to 4? Yes. So this relation is, so R is reflexive. So we know it's reflexive. Okay, maybe it's easier if we sketch the directed graph representing the relation. So let me sketch it. This is 1, 2, 3, and 4. So we know that, so this is 1, this is 2, this is 3, and this is 4. We know from this that 1 is related to 1, 1 is related to 2, 1 is related to 4. Okay, 2 is related to 1, 2 is related to 2, so we have an arrow relating 2 to itself, 3 as well, 4 and 1, so we'll have an arrow from 4 to 1, and finally 4 is related to itself. Okay, since every element is related to itself, then it is reflexive. Okay, so let me make the points with black. Now, what do we know also? So it is not irreflexive. Why? Because irreflexive means every element is not related to itself, but we have one element too, it's related to itself, so it's not reflexive. Is it symmetric? Symmetric means whenever you have an element which is related to itself, to another element, then the other is related to the first. So see here, we have an arrow from 1 to 2, and we have an arrow from 2 to 1. And here as well, 1 is related to 4, and 4 is related to 1. So this means it is symmetric. So check all the 1 is related to itself, and 1 is related to itself. So it's reflexive, it is symmetric. Now, is it antisymmetric? No. So it's not antisymmetric. Because what is antisymmetric? It means whenever we have an arrow between distinct elements, then we don't have the reverse arrow. But look, 1 and 4 are distinct. We have the arrow 1 to 4, but we also have the arrow 4 to 1. So this violates antisymmetry. It's not antisymmetric. Okay, now is it transitive? Also, it's not transitive. Why it's not transitive? Because look, 4 is related to 1, right? 4 is related to 1. Here is the arrow. I will use the red color. Now look, sorry. Look, 4 is related to 1, right? And 1 is related to 2. This, if it were transitive, 4 should be related to 2, but it's not. So it's not transitive. So 4 is related to 1, and 1 is related to 2, but 4 is not related to 2. This means it's not transitive. Since we found one example, one counterexample of transitivity, where a first element is related to the second, and the second is related to the third, but the first is not related to the third. So in this example, 4 is the first, 1 is the second element, and 2 is the third. And see, 4 and 2 are not related. 4 is not related to 2. Okay. So this is one example. Now let's take another example. Okay, take another relation on the same set, 1, 2, 3, 4, but let me draw it for you. Okay, so here we have 1, 2, 3, and 4. And 1, in this example, 1 is related to itself, 2 is related to itself, 3 is related to itself, and 4 is related to itself. And we have 1 is related to 2, 1 is related to 3. Sorry, I should write 1, 2, 3, and 4. And 3 is related to 4. What else do we have? 2 is related to 4. And 2 is related to 3. And 1 is related to 4. Okay, so we are given this relation, and what properties does this relation satisfy? So let's see. Is it reflexive? Yes, because every element is related to itself. Look, 1 is related to itself, 2 is related to 2, 3 is related to 3, and 4 is related to 4. So this is how you check that it is reflexive. You need to check every element is related to itself. So it is reflexive. Check. It's not irreflexive because irreflexive means no element is related to itself, but 3 is related to itself. So it's not irreflexive. Is it symmetric? No, because symmetric means whenever we have an arrow, we have a reverse arrow. So here, not symmetric. Why it's not symmetric? Because we have the arrow 1 to 4, because 1 is related to 4, but 4 is not related to 1. There should be an arrow from 4 to 1 in order for it to be symmetric. So it's not symmetric. Now, is it antisymmetric? I think yes, it is antisymmetric, because what is antisymmetric? It means, okay, so this, it means that whenever we have an arrow between distinct elements, we don't have reverse arrows. So let's mark in green all the arrows between distinct elements. So here is the arrow between 1 and 2. Here's the arrow between 2 and 4. Here's the arrow between 2 and 3, and this is the arrow between 2 and 4, and this is the arrow between 1 and 3. And look at this final arrow between distinct elements, 3 and 4. So to check antisymmetry, we don't care about arrows from an element to itself. We only care about arrows between an element and another distinct element. Why is this? From the definition of antisymmetry. Look, here is antisymmetry. For every two elements, if they are distinct and the first is related to the second, then the second should not be related to the first. Okay, so here are the green arrows, and look, for every green arrow, which is an arrow between distinct elements, we don't have a reverse arrow, right? We don't have reverse arrows, so this means it's antisymmetric. Look here, 3 is related to 4, but 4 is not related back to 3. Okay, so this shows antisymmetric. Now, is it transitive? The answer is yes, so it's transitive. How do you check transitivity? You need to check many cases. For example, you need to see that, okay, look here, 1 is related to 2, and, right, 1 is related to 2, and 2 is related to 4. And so this means we can conclude that 1 is related to 4. But it is the case. Look at this green arrow. 1 is related to 4. Okay, another example is 2 is related to 2, right? And 2 is related to 3. So this means that 2 must be related to 3. And it is the case. So you can check for every triples of numbers from 1 to 4, if the first is related to the second, then the second is related to the third, then the first is related to the third. Okay, here is another example. Okay, in red, let's say. So let's see. 1 is related to 4. Okay, we can't continue now. So I should, because 4 is not related, and 4 is related to itself, then 1 is related to 4. I want a more interesting example. So here, 1 is related to 3, 3 is related to 4, and you can check that 1 is related to 4. Okay, this is always the case. Okay, so it is transitive. Okay, let's take one last example. Here are the 3 dots representing the elements of the set A. So this is 1, 2, 3, and 4. And what arrows do we have? We have the 1 is related to itself, 1 is related to 2, and 2 is related to 1, and that's it. This is the relation. So here the relation is the pairs 1, 1, 1, 2, and 2, 1. You are given this relation. It's a relation containing 3 pairs. And is it reflexive? No, it's not reflexive, because reflexive means every element is related to itself, but 4 is not related to itself. Okay, since 4 is not related to 4. Okay, second, is it irreflexive? No, it's not irreflexive. Why? Because irreflexive means every element is not related to itself, but one is, since one is related to itself. So it's not reflexive and not irreflexive. Okay, so this shows that irreflexive and reflexive are not negations of each other. Okay. Now, is it symmetric? Symmetric means whenever you have an arrow, we have a reverse arrow. So here we have an arrow from 1 to itself. The same arrow is the reverse of itself, so check. We have the arrow from 1 to 2, and so we have the arrow from 2 to 1, and we have the arrow from 2 to 1, we have the arrow from 1 to 2. So every arrow has a reverse arrow. So it is symmetric. Okay, so check. Now it is not antisymmetric. Why? Because antisymmetric means whenever we have an arrow between different elements, we don't have the reverse one, but we have an arrow from 1 to 2, and we have an arrow from 2 to 1. So this violates antisymmetry. Now, is it transitive? So the answer is not transitive. Why it is not transitive? Why it's not transitive? Look here. 2 is related to 1. Let me write it in green. 2 is related to 1. And 1 is related to 2. So this should imply that 2 is related to itself. But it's not the case. So this shows that it is not transitive, because we found one triple of numbers of elements, which are, what is the triple? 2, 1, and 2. 1 is related to 2. Sorry, 2 is related to 1, and 1 is related to 2, but 2 is not related to 2. So it's not transitive. Okay, so again, to sum up, we talked about 5 properties of relations, which are reflexive, irreflexive, symmetric, antisymmetric, and transitive relations. Okay, let me give a final example of a relation which is both symmetric and antisymmetric. Okay, look at this one. So here's a relation on 3 elements, and look, say this element is related to itself and this element is related to itself. Then this is symmetric. Why it is symmetric? Because whenever we have an arrow, we have the reverse arrow, and it's antisymmetric as well. Why it's antisymmetric? Because antisymmetric means whenever you have an arrow between different elements, then you don't have the reverse arrow. But here we don't have arrows between different elements, so there's nothing to check. So it's trivially antisymmetric. Okay, remember, antisymmetric means for every A, for every B, if A is not equal to B and A is related to B, then B is not related to A. But there are, this hypothesis is always false, because we don't have distinct elements which are related. The only 2 elements which are related to themselves, right? Say this is A, B, and C. So you can't find A different from B and A related to B. So this is always false. This means that the whole statement, conditional statement, is true. So for every A, for every B, we have a true statement, and this means that it is antisymmetric. the relation is antisymmetric.